So now we will see some important terms used in filters. So number one is the characteristics impedance. It is denoted by capital Z naught. So consider that we have infinite number of symmetrical networks connected in cascade. So characteristics impedance is defined as the input impedance. So from the input side, we are looking at the input side and we will try to measure the impedance. The input impedance measured at the input terminal, input impedance, we are measuring it from the input side when an infinite number of symmetrical networks, are connected in cascade. So it is the input impedance when infinite number of symmetrical networks are connected in cascade. So even if I remove this network and if I see the input impedance from here, then here also it will be Z naught only. From here also the impedance will be, characteristics impedance will be Z naught. That is nothing but input impedance. So we have one T network, Z1 by 2, Z1 by 2 and Z2. So this Z1 by 2, Z1 by 2 addition is nothing but the series arm. This is the series arm and this Z2 is the shunt arm. This Z2 is the shunt arm. So we have one T network. It has a shape T, symmetrical T network. So your input impedance is nothing but the characteristics impedance Z0. When we will terminate our output with characteristics impedance. So input Zin equal to Z0 when your output is terminated with characteristics impedance Z0. So this is nothing but series Z1 by 2 plus Z0. It is in parallel with Z2. And after that, all this combination will come in series with this Z1 by 2. So overall our characteristics impedance Z0 is given by Z1 by 2 plus Z2 parallel Z1 by 2 plus Z0. So if you solve this equation, you will get Z0 equal to under root Z1 square by 4 plus Z1 Z2. So this is the formula of characteristics impedance for a symmetrical T network. For a symmetrical T network, this is the formula of characteristics impedance. So now next is find the characteristics impedance for T network. So one T network is there. So Z1 by 2 is 100 here. Z1 by 2 value is 100. So Z1 will be, this 2 will go to that side. So Z1 equal to 200 and Z2 is 400. We have the formula under root Z1 square by 4 plus Z1 Z2. So it comes out as 23.6 ohm. So this is the characteristics impedance for this T network. Simple question. Next is the propagation constant. Next term is the propagation constant. So again, the symmetrical networks are connected in cascade. So we have infinite number of symmetrical networks that are connected in cascade. So your propagation constant is giving the relationship. So something is propagating, right? So it is giving the relationship between the current entering in the network and current leaving the network. So it is giving the relationship between current in a network, that means current which is entering in the network, to the current leaving the network. So that relationship is given by this propagation constant. So we have this term e raised to gamma equal to incoming current is Is, outgoing current is I1. So Is upon I1, where gamma is called as the propagation constant. Here this gamma is called as the propagation constant. And it is nothing but alpha plus j beta, where alpha is the attenuation. So attenuation meaning is the signal level is reduced, and beta is the phase shift between these two currents. Phase shift between these two currents. So that is nothing but beta. That is called as phase shift. So alpha is the attenuation constant and beta is the phase shift. So your e raised to gamma can be represented as e raised to alpha angle beta, where e raised to alpha is the magnitude and beta is the angle. So e raised to alpha equal to magnitude is by I1. So if I take the log both side, so because of e here, I have to take natural log. So alpha comes out as ln magnitude is upon I1, and here the unit comes out as Napier. The unit of this quantity attenuation is Napier, Neper. Then third one is design impedance. Third parameter is design impedance. So your series arm is Z1, shunt arm is Z2. So between these two series arm and shunt arm, we have one relationship that the Z1 into Z2 equal to R0 square. So this R0 is nothing but the design impedance. R0 is nothing but the design impedance. So this is a real quantity and it is independent of frequency. Then fourth is the cutoff frequency. So whenever we are going from pass band to stop band, whenever we are going from pass band to stop band, we are having one frequency that is nothing but the cutoff frequency. Definition is it is the frequency at which the gain decreases by minus 3 dB. So here suppose gain is x. So when we come up to minus 3 dB, so that is nothing but cutoff frequency. So x-axis is the frequency. Also, it is the frequency at which there is a change in, or we can say transition from pass band to stop band, and vice versa. If it is a high pass filter, then we will have like this. So we are going from stop band to pass band. So here is the cutoff frequency. Okay. So once again, number one is characteristics impedance. What is characteristics impedance? It is the input impedance measured at the input terminal when infinite number of symmetrical networks are connected in cascade. And formula for T network, what is the formula? Z0 equal to under root Z1 square by 4 plus Z1 Z2. So we will see where we will require this formula. Accordingly, we will use. Otherwise, right now I don't feel that we will require to use this formula, but we can see. Then next is the propagation constant. So it is giving the relationship between current entering and current leaving the network. So e raised to gamma equal to Is upon I1. So something is propagating, right? Current is propagating. And gamma is nothing but alpha plus j beta, where alpha is the attenuation. Attenuation means somehow the current is decreases. There is some kind of force that is reducing the value, and that is nothing but the attenuation alpha. And beta is the phase shift between input current and output current. Then design impedance, very important. So it is the product of series arm Z1 and shunt arm Z2. And it is a real quantity. And last is the cutoff frequency. So whenever we have a transition from pass band to stop band, this is pass band, this is stop band, we are having cutoff frequency.